All right, hello everybody. Welcome to section 7 in chapter 4. So today we're talking about inverse linear functions. We've worked through a bunch of topics here. We're getting towards the end of this chapter, getting ready to review. But for today, we want to talk about these inverse linear functions. So we've worked on representing our relations and our graphs several different ways: tables, graphs, and mappings. Today we're going to work on this inverse of a relation. Inverse is the key today. So that is our vocab. You can have an inverse function or a relation, just two different ways of looking at the same concept. So given a set of points, what is an inverse? What does that mean? Well, if one relation has a point AB, so given a point, the inverse of it is when you switch the order. Switch B with A. So whatever was originally first now will come second. So given this point, notice what happens when we find the inverse. We switch them. 16 negative comes first. Negative 3 comes second. Notice the color change. First point became the second one. So we just really switch the x's and the y's. And that's it. So notice they all flip. That's what we're doing when we're given points to find the inverse. Inverse is the key here. Inverse relation. So we can see that in an example. So here's our first one. We're given 4 points. We're asked to find the inverse of these points. So given the steps we just talked about, we know we can find that. We exchange, which is another way of saying switch, the coordinates of each pair. So switch the first one and the second one. Bam, we get 26, negative 3. Follow that same logic. So where we have a 6, negative 1, switch their order. Bam, 1, negative 1, positive 6. That's it. Switch this, 11 and 2. Switch these, 20, negative 1. So in this process of finding the inverse of some points, just switch the order and then you're good to go. So our answer, starting with these 4 points, all we do is rewrite them given the x value and the y value now switched in the opposite order. No signs are changing. The signs all stay the same. We just switch the order. That's it. And that is our inverse given some points. So hopefully that makes sense as we jump into more complicated examples. But for this one, the inverse is the switching of each pair. So 26, negative 3, 11, 2, negative 1, 6, and a 20, negative 1. Switch those orders, put them in brackets, and then we are on and rolling to the next example. Okay, so given this table, we want to find the inverse. So even though our information is presented to us in a different way, it's still the same concept. So this is presented in a table instead of just ordered pairs, but we can still find that inverse by switching the order of each one. So each row here represents a point. So this row is the point negative 4, negative 3. So our information is just organized a little bit differently. But all we need to do then is still the same process, switch those orders, and find that inverse. So we'll exchange, a word which here means switch the order of the coordinates of each pair. So first one, switch these, we get A, and have this piece down, negative 3, negative 4. Given the point negative 2, 0, switch them, 0 comes first, the 2 with a negative comes second. Okay, same logic with the third point. 1, 4.5 becomes a 4.5, 1. So hopefully we're understanding this concept. With that same pattern, that same logic, 5, 10.5 would become 10.5, 5. So this is what we would get when we're given this table and we switch the order of each pair. Again, what are we actually doing here? We are finding the inverse of this relation. Inverse is the key. So for 1b, we're interested in these 4 points. 3, 4, 4.51, 0, -2, and 10.55. Have those in brackets as we pass along to the next problem. Now for 1c, notice we have some options. We want to find the inverse of these 4 points given. So we'll have that down to start, and I know my order needs to switch for each one of these. So if I switch the order of these two, I know I'm going to get then 8, 4. So this is not complicated in terms of steps. There's only really one step here. Switch the order and then write what you got. So switch the order here, I should get a 6 and a -6. Switch the order here. Notice these are the same, so that's going to stay the same. 3, 3. And the last one here, switch the order of these two. I get a -8 here and a 0 on the right. So let's look at our answer choice options. No, no, and yes. B is our solution. All the rest are in the wrong order in one way or another. So for 1C, we need to make sure we have these 4 points as that correct and perfectly done inverse given our example. Do we confirm? Yes, we do. B, for this example, that is what we need. That is our inverse. Okay, so given this, we have a real-world example too. We want to graph the inverse of this relation. So we worked with graphing points, or plotting points given an original and reversing the order. We can also graph, though, our inverse using the same logic of switching the point orders and then graphing our line again. So there's actually an inverse of this graphed line. So what's that going to be? Well, don't worry about all these words, but we will write down just the key points and then understand what's happening. So notice the blue line here, that's what we started with. And this purplish line here, that is the inverse of this original line. So if you pick, and this is how we found our inverse line, if you pick points that our line falls on, you can find the inverse of your line by switching the order of these points. So I'm just going to highlight a few points here, just so we can have a discussion about how we got there. So any points that you pick, and in this example, they could have picked any points, but they chose these that the line fell on, and switched the order of these points. Notice this point, -2, 6, became 6, -2. Now when they switch the order of these points and then plot that new line, that's how we get the inverse line. So say I pick these 3 points here. What are the coordinates of these? Well, this one is a -1, 4. And please write this piece down. We have a 0, 2. Again, this is in our original line given, 0, 2. Third one we have is a 1, 0. Okay, so we have those 3 points. Now we want the inverse of that line. And we know, since we've done it now a couple times, we know that to get our inverse, we need to switch the order of our numbers. So this would become then, let's switch our color. Our inverse line would be 4, -1. It would also contain the point 2, 0. And third, it would contain the point 0, 1. So since these would be points on the inverse line, we can then plot these points and see what our line would become. So if I go over to 1, 2, 3, 4, -1, I would plot this point, We're assuming now this line's not already here. We're trying to find it. And that's how this is proving how we would get there. So the next point would be 2, 0, 1, 2. Stay there. And the third point would be 0, 1, 0, 1. We would connect all these points with a line, just like that. And that's how we would get that inverse line. So pretty cool. This pink line is the perfect inverse of the blue line. Now, as a trick to help you understand and double check when we're doing these problems, every inverse function that you graph is actually a reflection about this diagonal line that goes perfectly across our graph, like this. So if you can kind of wrap your head around these lines tilting and reflecting about this line here that goes diagonally across your graph, you'll see that that mirror image across this line is perfect. It makes sense given the lines that we have. This line we call y equals x. This isn't something that you have to know yet, but it is helpful to just double check your answers. So if we reflect this blue line across our line y equals x here, this upper piece here would flip and get this piece here. And this lower blue piece would flip over and get this piece here. That's how we would get both of those lines. So that's something neat to know as we reflect across these. But the general idea you need to make sure you understand, change those points, change the order, plot them, and get your new line. So that is example 2, our first one there. So have that down as we jump into the next one. Okay, so here's another graph we can look at. And we want to graph the inverse of this thing. So how would we get there? Well, let's pick a couple points here that we can easily measure and track. And then we'll switch the coordinates of those points and then get our new line. Do you notice here, you should, that I'm picking points that fall on perfect corners in our graph? Because those are whole numbers that are easy for me to switch around. So this is the point, I'll start here, -1, -3. So let's go -1, -3. This point is 0, 1. Draw yourself an image of the graph and these points as we follow along. This is the point 3, 3. So now we have 3 points given. That's our original. So to get our new line, we need to switch the order. I'm going to change my color. Switch the order of these points. This is our original, and this is going to be our new line. So we'll switch the order, -3, -1. So let's plot that point. 1, 2, 3, -1. Second one will give us 1, 0. So this should make sense as we're just changing the order of these things. So 1, 0, 1, 0, stays there. And our last one is 3, 3, it stays 3, 3. So 1, 2, 3, 1, 2, 3. -3, -1. Oops, this should be a 0. This should be a 1, 0 here. Yes, so this point is actually 1, 0. So when we switch the order, we would get a 0, 1 on this one. So those are flip-flopped. So our new one will have the point 0, 1. So that should be 0, 1 here. And then our last point 3, 3 would stay the same. So if we connect all of this with a line, it should look like this. Close to those points, starting there, going off in this direction, just like that. So our line should look something like this, going across, Our lines meet up here at this point 3, 3, and then cross over right there. We should see it going down in this direction, and we see that intersection up here. So as we look at the perfectly done version of that, here's our new line. It goes down here, it intersects up there. You can pick any points you want in the world that this line has on it, switch the order, plot them, and you'll get your new line. So inverses, you want to pick some easy points, plot them, reverse the order, and get your new line. So hopefully that makes sense. We'll work through that in some examples. I think you'll enjoy those as you switch the orders, get your new lines. And then you can see, again, that line I told you is called y equals x. It goes diagonally across here. These lines are both perfectly reflected about that line that goes diagonal right through my graph here. You could fold the paper along this diagonal line y equals x that I'm cursoring over right here, and you would get these two lines to meet up perfectly. They're symmetrical about that line. So pretty neat. We'll see that in our examples as we work through it. So we found inverses with tables with graphs and with just points. Another way we can do it is with the equation itself. So this expression here, f negative 1x, means the inverse function of our original one. This means inverse function, f with a negative 1, and then you put your x. So how do we find the inverse? Well, all these steps really tell us what do we do to find the inverse? We switch x and y, and then we solve for y. So where you see an f of x, you change that to y. Then you switch y and x. Then you solve for y, and then write your inverse notation at the end. So what do all those steps actually mean? Well, let's look at an example. So here's example 3 type problems. Find the inverse of this function. So our original function just says f of x, and we know that means the same thing as y, equal to negative 3x at 27. So first step, we start with our original, what are we given? Now we'll change this f of x thing, we'll change that to y. So we see that here. So y equals all of this. Now to find our inverse of this equation, we switch y and x. So the x becomes a y, that's going to change, we'll see that. And our y will become an x. So we just switch those two just like we switched the order of the points. So switch them, that's our second step. Now that we have this, we want to get the y by itself. So our skills for being able to solve for a variable that we did in chapter 1 should be coming into play here. We need that y by itself. There are a couple things around it, so how do we get rid of them? We'll do the opposite operation. So to get rid of the 27, we'll subtract. And that'll give us this step. And to get rid of the negative 3, we know it's tied by multiplication, so we will divide. So y would equal x minus 27, all divided by a negative 3. So that answer then, if we look back, for at this step, we divide everything by negative 3. That's going to get us here. X over 3, we have the negative, plus a positive 9. That equals our y value. Now, what is our last step? What are we going to do here? Well, we'll change this y to an f of negative 1x. Because this symbol here means inverse. Why is it an inverse? Because we changed the x and the y. We flip-flopped them. We're living in the inverse of this function. So the inverse, it's like the upside down of this equation, will be negative x over 3 plus 9, and then we have that done. So that is our perfectly done inverse when you switch the x and the y. So the inverse of the original here is given as negative x over 3 at 9. So this is the piece we need to make sure we have for 3a. What do you do to find the inverse? Switch x and y, solve for y, make sure you have that symbol, and you're done. That's it for 3a. So hopefully now, given any example in the world, with these inverses, you should be able to find them using the same logic. So we'll switch here our y, or f of x, with the x, and then solve for that y. So first step, we have our original, change the f of x to a y, because we know those are the same. So we'll do that here. Now once we're at this step, what are we going to do? Well, we need to substitute and change the x and the y. So flip-flop these two. That'll get us here. And now we need to get the y value by itself. So to get y alone, what do? Well, we'll do the opposite operations. So to get rid of the minus 8, we'd add 8 to both sides. And then once we do that, how do we get rid of the 5/4? Well, to get rid of this 5/4, we have to multiply by the reciprocal, which is a fancy way of saying flip the fraction. If we multiply 5 over 4 times 4/5, because 4 over 5 is the reciprocal, multiply these two, these would all cancel out. 5 times 4 is 20, 5 times 4 is 20, that all becomes 1, and then over here we'll get a number when we do the same thing to both terms on the left. This is a 4 over 5 times all of this. So we'll get y equals, and then this expression here. So we'll see that finish on the next slide. So y equals this expression. We want to simplify this, distribute this 4/5 to both things. So 4/5 x, can't change that, plus 32 over 5 will give us that y value. Now, what's the last step to write these inverse functions? Well, we don't want it written as y, we want to change it to that symbol we talked about, f of x with a little -1 next to the f. Now this is a superscript, so it's a tiny -1 written above the baseline of our letters here. So f with a -1 superscript of x equals that expression. That is our inverse. That is our solution. So given our original, we know our inverse is written as this expression here. Now they have it written twice because this is that step before we distributed. So either of those would be accurate. I would prefer you simplify and distribute. So we're looking for 4/5 x plus 32 over 5. Now, given 3c, we want to find the inverse of this one. What do? Let's take those steps quickly and get there. So we know we'll change our f of x to y. That's equal to 12 minus 9x. Now to find the inverse, we change x and y. So this will become, and I'll change my color, x equals 12 minus 9, and our x becomes a y. So we switch the order. Now we have to solve for y. So I want to subtract 12 from both sides first. So I'll get x minus 12. It's a minus equal to -9y. Now what do? I need to get rid of this -9, so I will divide everything by that on both sides. So I should get a y over here, and it's equal to negative x over 9 plus 12/9. If we left this the same and didn't split our whole fraction, we would have negative x plus 12 over 9. So where do we see this as an option? It should be letter choice A here. So we should have our inverse as letter choice option A. Switch them around, solve for your variable, you get this expression here. So as long as you can understand you need to switch the x and y variables, you should be able to solve these problems. Okay, let's jump to example 4 today. You'll have some to look at in your homework that'll have some real context to them. So this one's talking about sales. They give you the total earnings for a month. That's this expression. X is the number of dollars you earn. So they say find the inverse. So we know we'll switch X and Y like we've already done. So even though there's all these words, I just want you to have the equation and then try to understand, wrap your head a little bit around the context. So there's our original. Switch f of x to a y, and now change x and y, switch them around. Let me get this. Now we need y by itself. So subtract away the 2200. You don't need that. So you'll get x minus 2200 on the left, and just 0.05 y on the right. So that gets us to this step. In a final step, divide both sides by 0.05. And what do we get? Well, we get 20x, because dividing by 0.05 is the same as multiplying by 20. So you get 20x minus this really big number, 44,000. And that is our inverse of this expression. So our answer then is going to be the inverse, remember that symbol, f negative 1x, equal to 20x minus that big number, 44,000. So hopefully we can understand, wrap our head around these types of problems, switch the x's and y's, find your inverses given whatever information you have. You have the tools, so let's now get to it.